All right, I was getting cut in short, so I'm going to start again on number 7. Determine whether the table is linear or quadratic. So the first one, the input values are equal length interval. Your output values, the second difference is the same. So I will say this is a quadratic because over the equal length input interval value, which is plus 1, the change of the rate of change is constant. Or the average change is linear. Or the second difference is the same, constant. All three are perfect reasoning. What about this one? Just by looking at it, this looks like a quadratic function. Same reason as this one. Over the equal length interval value, plus 2. The change of the average rate of change is constant, which is plus 1. Or average rate of change is linear, which is plus 3, plus 4, plus 5, plus 6. Or the second difference is the same. Third one. As soon as I see it, I notice they are not equal length interval values. They're not the same. So I can only check whether it's a linear or not. Let's look at the right side. What do you notice? Oh yeah, I notice that the average rate of change is all 1. What is average rate of change same as? The slope. The slope is all 1. So what is this? This is a linear. So I will say it's a linear because average rate of change is 1, 1, 1, 1. All the same. The last one, oh, the numbers are weird. Plus 0.4, plus 0.4, oh, they're not weird. Okay, plus 0.4, plus 0.4 over the equal length interval value, plus 0.4. What's going on with my output? I can't read my printer. What's going on? Negative 3.5, oh, it's a negative 3. All right, so looks like a linear because over the equal length interval value, my average rate of change is constant. Number 8, polynomial function. Okay, the fact that it's asking about the inequality, if you're here in students, I told you this is going to take a little while, so if I were you, I'll mark it, come back to it later. It's not hard, it's time consuming. But the good news is this is a polynomial function, meaning like the different degree. We did learn a shortcut of doing it, so let's go. First thing, you're going to go ahead and find the 0. Set each factor equal to 0, so x is equal to 0, x is equal to 3, x is equal to negative 2. You're going to put them in a number line in order, negative 2, 0, and 3. Determine what kind of circle you want for your 0. The fact that problem wants strictly less than 0. Let me double check it. Oh, yep. Just did not print less than equal to 0. I want my 0 to be closed circle. You do want to include your 0. So I'm going to go ahead and close it up so I can include those. Now, in class, I told you guys to pick a number here and then plug it in to determine the sign. So I'll show you quickly what that looks like. So for example, choose negative 3. You're going to plug it into here and here and here and tell me the sign. What is the sign of negative 2 times negative 3? Positive. Be careful, there's a negative there. And what is the sign of negative 3 minus 3? Negative. What is the sign of whatever square is always going to be positive? So positive, negative, positive is going to be negative. So I'm going to do that here and here and here. However, as I said earlier, this is a polynomial function, so I can just quickly sketch it. How? Using the n behaviors. Yeah? All right. What is the degree of this function? X times x times x squared. Oh, the 4th power. This is the 4th degree. What is a leading coefficient? Negative 2. So it's going to be negative leading coefficient. If you wanted to, you could have actually done this. Negative 2x times x squared. Negative 2x to the 4th power. Use that. All right. Either way, you got the negative leading coefficient. Right hand goes down. Even degree down and down. And what about the zeros? Okay, at negative 2, what's a multiplicity? 2. So, watch this. I'm going to go ahead and sketch it. It starts from the down. At negative 2, multiplicity is 2. So, it's going to bounce it back up, down. At 0, it's a multiplicity of 1. So, it's going to go straight through it. And at 3, it's a multiplicity of 1. So, it's going to go straight through it. So, this is what it looks like when I sketch it. You good? What am I looking for? Less than equal to 0. So, I want the negatives. Shade, let's go. These are the negative because under the x-axis, that's a negative, that's a negative. Now you just have to write that in arrow notation. Let's go. negative infinity, include, so do not pause at -2. You gotta go all the way to the 0, but it's a closed circle bracket. Union, I don't need that because that's a positive, starts again at 3 to positive infinity. Close it up. Okay. I just noticed the key is wrong. Okay, well, good thing we cleared that. Number 9. Consider, okay, so this is F, this is G. Find the points of intersection. How do you find when you have two functions and looking for the point of intersection? We've done it a few times in class. You set them equal to each other. So I'm going to set f of x equal to g of x. Like that. Yeah? All right. Let's combine these two together. Natural log positive. That means you can multiply your arguments together. Both of them have a natural log. There's nothing in the front, so it's like the same thing. I'm only going to take my argument and set it equal to each other. Like this. So x times x minus 3 is equal to 10. Distributed. I'm going a little fast. If you're having a hard time with this, pause it and then take notes or make sense out of it. Quadratic equation, you're going to set it equal to 0. You're going to factor ACB chart. Your zeros are 5 and -2. Once you find your zeros, remember this is the logarithmic equation, so you do have to check for extraneous solution by plugging it back in. Let's start with the 5. 5 positive, 5 minus 3 positive. You're good. What about -2? Natural log of -2 is invalid. So sorry, that's your fake solution. Only solution become 5. Find the equation of the horizontal or slant asymptote. So horizontal asymptote has to do with the degree, right? So when degree of the top is bigger than degree of the bottom, there's no horizontal asymptote. It's going to have a slant asymptote. It's the same degree. It's going to be y is equal to leading coefficient over leading coefficient. The bottom is bigger. Y is equal to 0. Quick reminder. All right, so let's go. If I can see. All right, degree of the top is 2, degree of the bottom is 2. So horizontal asymptote is y is equal to leading coefficient 1 over leading coefficient 2. Half. Next, degree of the top is 3, degree of the bottom is 2. So no horizontal asymptote. But I do have to find the vertical slant asymptote. Ugh. So you're going to go ahead and divide it. Plus 4x minus 1. If you're reverse side, folks, you might want to use the box method. All right, let's go. X squared times what is that? 3x. Multiply 3x cubed plus 6x squared minus 15x. I'm going to subtract it. Negative 6x squared plus 19x minus 1. X squared times what is negative 6? Negative 6. Negative 6. And I don't even have to fill it out because I don't care about the remainder. That's your quotient right there. Y is equal to 3x minus 6 is your slant asymptote. Sorry, I'm rushing. All right, what about this one? Degree of the top 3, degree of the bottom is 3. Oh, yeah. Y is equal to the leading coefficient over leading coefficient is y is equal to 5. Okay? All right. The value of a new car is modeled by the function. The value is decreased by 1.8 each month. This is an exponential function. A times 1 plus r to the t power, a times 1 minus r to the t power. I'm bringing your algebra to that. In this case, it's decreasing, so we're going to use this one. Initially, car was 25,000, so a value is 25,000. 1 minus, what's the rate? 1.8, but remember, you got to move your decimal 2 to the right, so it's going to be 0.018 raised to the t power. And it's decreasing each month. So each month, I'm just going to write that for a second. Each month. Okay, let's clean it up. I got 25,000. I can't subtract it. What is it? 0.982. Hopefully that's right. Each month, each month, each month. Okay, but the problem here is that they want what? T to be number of years. Ugh. Okay, so I'm going to write the same thing, but they want number of year. So let's think about it. And the number of year to be T. How many months are in 1 year? So if I put 12 here, that should be same as T equal to 1. Right? Because that's each month is happening. So it happens 12 times, is same as when t is equal to 1. So what do I have to do to this 1 to make it 12? You need to multiply by 12. So I'm going to multiply this t by 12. So I got 25,000.982 raised to the 12t right here. I just noticed the key was wrong. It should be minus because it's depreciating. Okay? All right, keep going. Find all real zeros and non-real zero. Okay, so I'm going to set everything equal to 0. It's kind of partially factored, not yet. X squared plus 9 is equal to 0. X squared is equal to negative 9. Square root both sides. But when you square root it, folks, don't forget plus or minus. That's where you're going to make the most mistake on. The fact that negative is inside of the radical, that means I comes out. And what's square root of 9? 3. So x is equal to plus or minus 3i. What about this? X squared minus 9 is equal to 0. Some of you are like, Mr. Major, that's x plus 3x minus 3. Correct. You can do that. Or you can solve it like how I just did the right side, square root both sides. But when you do that plus or minus, x is equal to plus minus 3. So guess what? You got 4 solutions. 2 real solutions, 2 imaginary solutions. X is equal to 0. X squared minus 16 is equal to 0. The same thing. X is equal to plus or minus square root of 16 plus or minus 4. What about this? X squared is equal to negative 64. Square root both sides plus or minus. Negative inside. I comes out. Square root of 64 is 8. So you got 1, 2, 3. 3 real solution and 2 imaginary solutions. So it's a 50. Wow, this is long. All right. Determine it's an exponential or logarithmic function. Okay, look at the time. So my inputs are multiplied by 1/3 proportional. My outputs are additive plus 2. So I'm going to say that's a logarithmic. Give a reason, because while my inputs are proportional, my outputs are equal length intervals. What about the second one? Plus 3 times 2. So this is the other way. That will be the exponential function. Over the equal length input interval value, my outputs are proportional times 2. List the transformation that were done to the parent function. All right, remember, when you list them, please talk about the shift at the end, which I like. So I'm going to write at the end. 5 up, 2 left. That half, what does that half do? Vertically stretched by a factor of half, meaning it got shorter by half. Done. Next one, you got 1, 2, 3 things going on. I'm going to shift 1 down later at the end. 4 means vertically stretched by a factor of 4, meaning it got taller 4 times. Be careful here, it's a 1/3 times x. That means horizontally stretched by a factor of 3, because remember, you the reciprocal of it for the horizontal. Next one, a lot going on, geez. 1, 2, 3, 4, 5, I think. Yeah, all right, 2 up, 3 right. That 4 is multiplied in front of the x, so it's going to be what? Horizontally dilated by a factor of 1/4, meaning it got skinny by 1/4. That negative 3 actually does 2 things. Negative does what? Y change the sign. X a reflection. And that 3 does vertically stretch by a factor of 3. Sorry, I'm not writing. Next. I can't. I gotta make another video.